While the whole world is watching the conflict in the Middle East, seismological stations in neighboring Armenia have registered strange seismic signals. Scientists immediately compared the obtained data with archives. The picture exactly matched the seismograms of the first underground nuclear tests in Pakistan in 1998, when a plutonium device with a yield of 20 kilotons was detonated in the Quran Desert. Coincidence? Unlikely. Over the past 6 months, several strange earthquakes have already occurred in areas of Iranian nuclear facilities. On June 15, a tremor of several magnitude points shook the underground uranium enrichment plant in Fordo. On June 20, an earthquake of magnitude 5.1 struck the same Semnan Desert, where underground test sites are possibly being built. According to IAEA data, the country officially enriches uranium to 60%, just one step away from weapons-grade level of 90%. Today we will examine what is really happening under the sands of Iranian deserts, why seismologists around the world are carefully studying every underground tremor in Iran, and whether recent earthquakes are connected to nuclear testing. Imagine you are a geologist and suddenly notice something strange on seismic station monitors. An earthquake of magnitude 4.5 in the Iranian desert. It would seem like an ordinary occurrence for this seismically active region, but the graphs look completely different from how they should. The curve of underground disturbance power unexpectedly and instantly shoots upward and then immediately disappears as if nothing happened. No preliminary tremors, no aftershocks, only one sharp peak. Exactly such a picture was recorded by Armenian seismologists in October 2024 when their sensors detected a strange underground event in Iran's Semnan province. The patterns on the graphs looked eerily familiar. This is exactly how the seismograms of the first underground nuclear tests in Pakistan in 1998 looked. Ordinary earthquakes develop completely differently. A series of tremors begins with lower intensity and gradually reaches maximum, then smoothly fades, leaving characteristic aftershocks that can continue for days and weeks. It's like a stone thrown into water. First, a big splash, and then the spreading circles become smaller and weaker. What happened in Semnan was more reminiscent of a firecracker exploding underwater, an instant strike in silence. For geophysicists, this is a red flag the size of a football field, especially when it comes to a country that has been balancing on the brink of creating nuclear weapons for several years. Iran is located in one of the most seismically active zones of the planet at the junction of the Arabian and Eurasian lithospheric plates. Here, earthquakes are commonplace. Over the past 30 years, the country has experienced many destructive tremors, from the catastrophic Bam earthquake of 2003 that claimed 26,000 lives to recent events in Kermanshah. But against the background of this constant seismic activity, events occurring near the country's nuclear facilities look especially strange. On June 15 of the same year, another suspicious event occurred. An earthquake of magnitude 2.5 in the area of the underground nuclear facility Fordo in Qom province. This facility, located at a depth of 80-90 m under rocky terrain, is one of the key elements of Iran's nuclear program. Here, uranium is enriched, and this is done quite actively. But here begins the most interesting part. Seismic activity in the Fordo area raised experts' fears about possible damage to infrastructure containing radioactive materials. After all, if uranium storage facilities or centrifuges are destroyed in an explosion, radioactive contamination could affect huge territories. Especially considering that Fordo has already been subjected to sabotage. In 2013, an explosion occurred here, whose exact causes remain a mystery to this day. Many experts are divided in their opinions. Some believe that all recorded tremors are the result of natural seismic activity in the region, amplified by man-made factors. Others see signs of something more sinister in the strange seismograms, and a third group suggests that Iran could have used the seismically active region as ideal cover for hidden testing of nuclear technologies. To understand how serious experts' suspicions are, we need to understand how seismographs work and what exactly they register. When an earthquake occurs, the Earth's crust generates two main types of seismic waves, P waves and S waves. P waves move faster. They are the first to reach seismic stations but cause relatively little damage. S waves follow, moving slower, but they are responsible for the main destruction. In an ordinary tectonic earthquake, the S wave has a noticeably higher amplitude than the P wave. It's like an echo in the mountains. First, you hear a clear sound, and then a long, powerful echo. But when an explosion occurs, especially an underground nuclear one, the picture changes dramatically. The P wave becomes dominant while the S wave is either very weak or absent altogether. This is a physical feature of explosive processes. Energy is released instantly and equally in all directions. Another key parameter is the moment tensor, a special diagram that shows exactly how blocks of Earth's crust move during a seismic event. In an earthquake, you will see a characteristic pattern of white and blue areas showing the direction of movement along the fault. In an explosion, the picture is completely different, an almost solid blue circle, meaning uniform expansion of material in all directions. Exactly such a moment tensor was recorded by seismologists during North Korea's underground nuclear test on September 3, 2017. Then the DPRK detonated a device with a yield of about 250 kilotons at a depth of several kilometers. Seismic stations around the world instantly determined the artificial origin of the tremor. The graphs left no doubt. But with Iranian events, everything is not so clear-cut. The earthquake on June 22, 2025 with a magnitude of 5.1 demonstrated a moment tensor characteristic of a normal fault, not an explosion. The S wave was stronger than the P wave, the epicenter depth was 10 kilometers. Everything pointed to natural tectonic origin. But events in Semnan in October 2024 looked much more suspicious. The problem is that modern technologies allow masking nuclear tests as natural earthquakes. If an explosion is carried out in the right place and at the right time, for example, in a seismically active region during a natural earthquake swarm, distinguishing it from a natural event becomes extremely difficult, especially if the HEEPS device's power is relatively small. This is exactly why international organizations use an entire network of control methods. The modern nuclear test monitoring system resembles a giant web in which it is virtually impossible to hide a large nuclear test. But the key word here is large. Low-yield devices, especially if they explode deep underground, can remain unnoticed or be attributed to natural causes. And to create the first nuclear weapon, a country doesn't need megaton warheads. A device with a yield of several kilotons is sufficient, which is technically much easier to camouflage. The Comprehensive Test Ban Treaty Organization analyzed data from its 250 stations and officially stated that events in Iran correspond to ordinary earthquakes. However, skeptics point to several alarming moments. First, the depth of most suspicious tremors was exactly 10 kilometers. A standard value that seismologists use when precise depth is difficult to determine. Second, some events occurred in sparsely populated areas where independent observations are practically absent. Third time, intervals between suspicious earthquakes too conveniently coincided with periods of escalating tensions around Iran's nuclear program. The story of the underground Fordo facility is especially interesting. This complex was built in secret and opened to international inspections only in 2009. Located in mountain tunnels, it was initially designed as protected from airstrikes. But now experts suspect that its underground location may be used not only for protection from bombing, but also for concealing some other activities. Iran's nuclear program began back in the 1950s when the country received its first research reactor from the USA under the Atoms for Peace program. The irony of fate is that it was precisely the Americans who laid the foundation for what today causes such a headache. In 1967, Tehran University received a training reactor with a capacity of 5 megawatts, which was supplied with more than 5 kilograms of highly enriched uranium and 112 g of plutonium for research. After the Islamic Revolution of 1979, the nuclear program was frozen, but in the 80s it resumed with Russia's help, which completed the nuclear power plant in Bushehr. Gradually, Iran began developing its own uranium enrichment technologies, and this is exactly where problems began. Uranium enrichment is the process of increasing the concentration of uranium-235 isotope, which is used both in peaceful nuclear energy and in nuclear weapons. The enrichment process occurs using gas centrifuges that rotate at speeds of tens of thousands of revolutions per minute. Today, Iran operates several key nuclear facilities where such activities take place. Natanz is the main uranium enrichment enterprise where thousands of such centrifuges are installed. It was precisely Natanz that became the target of cyber attacks and sabotage. In 2010, the Stuxnet virus disabled almost 1,000 centrifuges, making them rotate at incorrect speeds and self-destruct. And in 2021, an explosion occurred at the facility, which Iranian authorities called a terrorist attack. Fordo represents an even more protected facility built deep underground in the mountains of Qom province. It was initially planned as a secret backup enrichment center in case Natanz would be disabled. Fordo's existence was declassified only in 2009 when Western intelligence obtained irrefutable evidence of its construction. The Arak reactor, which produces plutonium, is an alternative path to nuclear weapons. The plutonium path is technically more complex than uranium but provides more compact and powerful warheads. It was precisely plutonium bombs that were detonated in Nagasaki and at the Nevada test site. Iran claims it uses the reactor exclusively for producing medical isotopes, but experts are skeptical of these statements. First, the country exceeded limits on accumulating low-enriched uranium, then began enriching uranium to 20%, and by 2021 reached 60%, a level that has no peaceful application. The situation is complicated by the fact that Iran began restricting inspectors' access to its nuclear facilities. Some surveillance cameras were disconnected, access to certain zones was prohibited, and cooperation with agencies was reduced to a minimum. This creates an information vacuum in which rumors and speculation flourish. Under these conditions, every earthquake in Iran, every strange seismic signal is viewed through the prism of nuclear confrontation. Maybe this is a paranoid perception of reality, or maybe the paranoia here is quite justified considering the stakes of the game. Analyzing all available data, we have come to contradictory conclusions. On one hand, technical analysis of seismic waves does not confirm the hypothesis of nuclear testing in Iran. Moment tensors, epicenter depths, P and S wave ratios, all this points to natural tectonic origin of most suspicious earthquakes. The Comprehensive Test Ban Treaty Organization conducted a thorough analysis and found no signs of artificial explosions. On the other hand, too many coincidences raise questions. Earthquakes occur precisely in those regions where nuclear facilities are located or secret test sites may be situated. Time intervals between seismic events strangely correlate with periods of international tension, and some characteristics of waveforms still differ from typical earthquakes of the region. Perhaps the truth lies somewhere in the middle. Iran may be conducting not full-scale nuclear tests, but tests of individual components, explosive lenses, detonators, fissile material compression systems. Such experiments don't require nuclear material but allow perfecting technologies necessary for creating warheads. Detecting such tests is extremely difficult, especially if they are conducted in a seismically active region. Another possibility is that Iran is indeed developing underground nuclear test sites, as written by the American Foundation for Defense of Democracies back in 2019. Construction of such facilities requires large-scale earthworks which may be accompanied by seismic activity, but this activity has man-made, not nuclear origin. There is also a third scenario. Iran consciously uses natural seismic activity of the region to mask its actions. The country may intentionally conduct questionable experiments during natural earthquakes, counting on artificial signals getting lost against the background of tectonic ones. In this atmosphere of suspicion and distrust, even the most innocent events acquire sinister coloring. Perhaps the strange earthquakes in Iran are indeed just earthquakes, and everything else is a product of analysts' inflamed imagination. Or perhaps we are observing the first signs of tectonic shift not only in the Earth's crust, but also in world order. If it was interesting, give this video a like.